So I'll start with the very basic simple circuit, which will be using Ohm's law as the basis, and there will be Kirchhoff's voltage law, which is called KVL. So I'll be telling you a lot of things, but what exactly to write in the experiment as journal, that will be a little shortened version of this. So what all I'm discussing today, everything will not go into experiment 1 part A, because experiment 1 is about series and parallel circuit, obviously resistive and with DC input. But in this resistive series circuit only, I have packed a lot of information. I have uh, just given you some instructions, what to do, what not to do in lab conduction of DC resistive circuit, because this being the primary circuit, I am telling you all those instructions. Not every day all those things will be told to you. So that's why this experiment, so I have made around 10 to 11 slides, and towards the end we will find what is the observation table that we have to fill up. Okay, so I'll start with this experiment. This is called as series resistive circuit or resistive series circuit. And this whole experiment number 1 will be having the name of series and parallel circuit or resistive series and parallel circuit. Okay, so experiment 1 part A I'll do now. Part B maybe I'll record the lecture and send to you, or maybe next week we will see it. We will see, we'll let you know exactly what is to be done with parallel circuits. So this is semester 3 network analysis lab. I think this is the first lab. So in first year you are familiar with all these things like CRO, what is digital voltmeter, or actually it is called multimeter. So multimeter is having multiple measurement capabilities in it. One is voltmeter, one is ammeter, one is ohm meter. So there are two probes coming out from the multimeter, one red, one black. Generally red is connected to the signal, black is connected to the ground. So for this experiment, we will require only two of those instruments. One is a DC power supply source, from where we can adjust voltage, from where we can adjust current also. And second one, what we require is a multimeter. So multimeter will be having resistance measurement facility, current measurement facility, and voltage measurement facility. So one very important thing, we know that whenever we want to measure resistance, we connect the ohm meter in parallel to the resistance. When we want to measure voltage, then also we put the multimeter into voltage range. If it is series voltage, then we keep in series DC voltage range. If it is AC voltage measurement, we keep it in AC voltage range. And we connect the voltmeter in parallel with the resistance across which we want to measure the voltage. And lastly, whenever we want to measure a current, so it can be AC current, it can be DC current, we have to select the range accordingly, and we have to keep the ammeter in series with the component through which we want to measure current. So this lesson is very easy, that keep voltage, connect voltmeter into parallel, connect ohm meter into parallel, and connect ammeter into series. So while you are doing numerical, solving numerical, at that time actually we are not connecting voltmeter, ohm meter and all. Actually we are finding all those values. But while doing experiments, students are generally confusing that how to connect it in series, how to connect it in parallel. So that is the main caution, and how to actually understand it, what to connect in series, how to connect in series, that we will discuss a little bit today. So what all we are discussing here today, not everything will go into journal. So what to write in the journal will be a lot shortened version of this. So be with me, listen the things carefully, and I'm recording this lecture. This lecture will be uploaded in YouTube and the link will be shared to you. So whichever practical I conduct over Google Meet, everything will be recorded, and it will be sent to you over YouTube link, so you can check that session later on. Slides also I will send to you in PDF format. So understand things properly, and whatever doubts you have, please send your doubts in the chat box immediately. Do not hesitate. Okay. So this is a series resistive circuit. You can see what all you can see is there are three resistances I have shown. One is R1, one is R2, another is R3. and all the three resistances have formed a loop, and I have given a DC supply. I know this is a DC supply because I have shown plus and minus here. So the symbols are very important. Whenever you are showing DC voltage, DC current, you should show which direction is positive, that means at higher potential, and which is negative. So three resistances I have connected. So this is going to be your circuit for series resistive circuit. It's a very simple circuit, and we know very easily that total resistance in the circuit is R1 plus R2 plus R3. Okay, that is the total resistance. And supply voltage V in I can mention. So you can take voltage as 10 volt or 15 volt, 18 volt, whatever we require. So during practical exam, I will tell you, okay, take voltage input as 8 volt. So in that case, you have to take 8 volt from DC power supply source. You have to check which is positive, which is negative. Then you have to choose three resistances. Let's say you choose 1 kilo ohm, then 470 ohm, and then 100 ohm or something. Okay, and you have to tell me how much is the overall current in the circuit, which is called as I in. So you have to give a name to the supply voltage. These are variable declaration. So you have to give input voltage as V in, name of the resistance as R1, R2, R3. And as is a series circuit, you can just change the position of resistances. It does not matter. Circuit and parameters will be same. So if this is 1000 ohm, this is 470 ohm, this is 100 ohm. In that case, whatever will be the current in the circuit. If you exchange the value of resistor, so you make this thing first R3 100 ohm, this thing you make R1 1000 ohm, and this thing you make R2 470 ohm. In that case also, overall circuit current will remain same. So 2-3 things are required here. First thing is, what is the input voltage? It will be given to you. What are the resistance values? You can choose the resistance values, or examiner can give you the resistance values. Three resistance values you have to take. Now you cannot take, so these are the real practical issues I'll be telling you. A lot of things I'll tell you, so keep listening intently. Now resistor values, you cannot choose anything. Somebody just said a 129.3 ohm. That is not possible. Okay, so there are some standard values of resistance which are existing in the market. If I ask you if there are 40 ohm resistor, answer is no. If there are 47 ohm resistance, answer is yes. If there are 470 ohm resistor, answer is yes. Okay, so if there is a 430 ohm resistance, answer is no. Okay, so there are certain standard value of resistances. So you have to practice that. You have to get the list of that from internet also, you can get it. And the standard value of resistances in the tens range, it can be 12 ohm, it can be 18 ohm, it can be 22 ohm, it can be 33 ohm, it can be 47 ohm, it can be 50 ohm, it can be 56 ohm, 68 ohms, and there can be 100 ohm resistance. But there is not a, somebody says 125 ohm, that resistance is not there. Okay. In kilo ohms range, if you want, it can be 1 kilo ohm resistance. There is 1.2 kilo ohm resistance. There is 2.2 kilo ohm resistance. There is 1.8 kilo ohm resistance. There is 3.3 kilo ohm resistance. 4.7 kilo ohm resistance. 5.6 kilo ohm resistance. So there are certain standard values of resistances. Okay. So whenever you are choosing R1, R2, R3, so 3-4 different ranges you can choose, and you can do this experiment. So what are things we are supposed to calculate first? So whenever you are doing some experiment, there are two steps. First one is calculation. So first I mention you what is the V in voltage. I tell you what is the R1, R2, R3. You have to calculate what is I in. So all the calculations you have to do. Then maybe you have to find what is the power across R1 resistance, R2 resistance, R3 resistance. What is the power, total power given in the circuit. So I'm making the experiment unnecessarily or not unnecessarily, I'm making the experiment a little complex. So it is not only voltage and current. So there may be the power calculation also